Hello everyone, welcome to my class. Today we are going to discuss about the vernier caliper and its functioning. Okay, so without wasting time, let us start the class. Students, vernier caliper is a measuring instrument which is used to measure length precisely and accurately, and it is also called slide calipers. I am going to show you why is it called a slide calipers. Okay, not to worry. And it is used to measure the length of a rod, measure the diameter of sphere, measure internal and external diameters of a hollow cylinder. See, we cannot measure these things using a metric ruler. That's why we need a vernier caliper. Okay, now we are going to discuss about the construction and working process of a vernier caliper. Okay, students, vernier caliper, as you can see in my hand, it comes with a long metal strip graduated with some markings and fixed with one of the jaws at one side. Okay, this is the main scale of vernier caliper. And there is another scale, the vernier scale. It slides over the main scale, as you can observe. Okay, and it has also markings over it graduated, and those markings can vary. General vernier caliper has 10 divisions in the vernier scale, and the vernier scale has a jaw, and you can see that there are two jaws downwards and two jaws upwards. Okay, we will discuss about these jaws. And another thing is that there is another part of the vernier scale that is behind. You can see that when I slide the vernier scale over the main scale, there is a metallic thin strip that comes out, but it is not visible when I keep the vernier caliper at its general position. Okay, so the thin metallic strip is behind the vernier caliper and it is hidden behind it. Okay, it moves with the vernier scale. Okay, as you can see. So, and there is a screw over here. If I tighten the screw, the vernier scale doesn't slide over the main scale. Okay, see, when I slide the vernier scale over the main scale, you can clearly see that the jaws, they are parallel to each other. The lower jaws are outside jaws and the upper jaws are inside jaws. The lower jaws are used to measure the diameter of any sphere, the length of any rod, and you can measure the external diameter of anything. And the inner jaws, they are used to measure the internal diameter of any cylinder, bottle, anything. Okay, so these are used for internal measurement, and these jaws, the outside jaws, are used for external measurement. Okay, and what is the process of measurement we will discuss later on. Okay, this is the construction. And what about this strip? This thin strip, actually we can measure. See, if I move the vernier scale, you can see that it goes to a depth. So we can measure the depth of a cylinder. Okay, so these are the basic construction of the vernier caliper. One thing is to remember that the vernier scale that slides over the main scale has 10 divisions in general, having the length of 9 mm. But there are other vernier calipers as well which has 20 divisions, 25 divisions, 50 divisions on the vernier scale. So they would have the length of 19 mm, 24 mm, 49 mm, and so on. So that depends upon the vernier caliper, and we use them for more accurate measurement. Okay, students, we have already discussed about the least count of the vernier scale. What is that? It is actually least count is equal to value of one division of main scale divided by number of divisions on the vernier scale. So we can write least count is equal to x by n, where x is the value of one division of main scale and n is the number of divisions on the vernier scale. There is another property of vernier scale, that is the zero error. That is also very much important for the calculation of length. So let us now discuss about the zero error of vernier caliper. Okay, students, as you have already discussed, the zero mark of the main scale coincides with the zero mark of the vernier scale when the moving jaw, this is the fixed jaw of the vernier caliper, this is the moving jaw, when it is in contact with the fixed jaw, then the zero mark of the main scale should coincide with the zero mark of the vernier scale. And another thing that is to be observed, that when the two jaws are in contact, the metallic strip that is behind the vernier caliper, it doesn't come out of the main scale, it hides in a proper way. So in that case, the vernier caliper is called free from zero error. That means the zeros are coinciding with each other. Which zeros? Zero of main scale and zero of vernier scale. But sometimes it happens that because of any mechanical error, the zero of vernier scale doesn't coincide with the zero of main scale. In that case, we say that the vernier caliper has zero error. Sometimes students misunderstand this, that zero error means no error. No. It is called zero error because the coincidence of the zero has some error. That is why it is called zero error. As we have already discussed, that when zeros coincide, then we calculate the least count and the proper length or accurate length of any object. So if zeros don't coincide, then what happens? The difference between the marking, that means zero on main scale and zero on vernier scale, that is actually has to be accounted for accurate or precise measurement. So the calculation of zero error is very important. And zero error are of two types. There are two types: positive zero error and negative zero error. Okay. We are going to discuss in detail about positive zero error and negative zero error. You just need to keep it in mind that the positive zero error and the negative zero error, that depends upon the location of the marking of zero on vernier scale in accordance with the marking of zero on the main scale. Because sometimes it happens that the marking on vernier scale, it goes ahead of the marking of main scale, and sometimes it falls behind the zero marking of the main scale. So we are going to discuss about these zero errors now. Okay, students, after bringing the two jaws of the vernier caliper in contact with each other, if we find that the zero marking of the vernier scale is towards the right of the zero marking of the main scale, then we say that the vernier caliper has positive zero error. Okay, positive zero error. That means towards right. Okay, right of the zero marking of main scale. As you can see in the diagram, the zero marking of the vernier scale stays toward the right of the zero marking of the main scale. One more thing you can observe from the diagram, that the sixth division of the vernier scale is coinciding with one of the division of the main scale. That is vernier scale division, that is sixth division. Okay, so this helps us to find out the zero error. Now what we need to do, we need to multiply this with the least count. So zero error would be 6 into least count. So what is the least count? 6 into 0.01 centimeter, that is equal to 0.06 centimeter. So this is the zero error. But we need to keep it in mind that when the zero error is positive, the sign is also positive. So this is positive zero error. We will later on discuss how we are going to use this positive zero error in case of measurement. Okay, let us now discuss about the negative zero error. Okay, students, in a vernier caliper, if the zero marking of the vernier scale lies towards the left of the zero marking of the main scale, then we call that the vernier caliper is having negative zero error. As you can see in the diagram, the zero marking of the vernier scale lies towards the left of zero marking of the main scale. One more thing that is to be observed, that the sixth division of the vernier scale coincides with one of the division of the main scale. Okay, that helps us to find out the zero error as we have discussed in the positive zero error section. But in this case, what we need to do, we need to concentrate on the position. It is behind 0, so we need to put a minus mark. And what we need to do, we need to subtract the number of division that is coinciding with one of the division of main scale from the total number of division, that is 10 minus 6. Okay, that gives us minus 4. Now what we need to do, we need to multiply this value with the least count. So minus 4 into least count, that is minus 4 into 0.01 centimeter, which gives us minus 0.04 centimeter. So this is the zero error. Okay, zero error. So let us now discuss what is the role of zero error in case of finding out the length of any object accurately or precisely. Students, we have discussed about zero errors. Okay, so correction due to zero error, that means how we can get the correct reading if the vernier caliper is having zero error. We need to remember that the correct reading would be equal to observed reading. That means the value that we have found out after the calculation minus zero error. Okay, but you need to remember one thing, that the zero error has to be with its sign. That means if it is positive zero error, then we need to write down plus the value, and if it is negative zero error, we need to write down minus and the value. For example, in the previous cases, as the zero error was minus 0.04, the negative zero error. Suppose the observed value is 2.37, then the correct reading would be 2.37 minus 0.04. We should not write 2.37 minus 0.04. It should be 2.37 minus 0.04. And as we know the sign conversion process, so it has to be 2.37 plus 0.04. That gives us 2.41. So 2.41 would be the correct reading for that particular measurement. Okay, we need to remember this thing. Okay. Students, let us now discuss the procedure of measurement of length of an object using vernier caliper. Okay. So let us now measure the length of the cap of a whiteboard marker. So for that, what we need to do, we need to loose the screw and keep the jaws away from each other. Then we need to put the cap in between the jaws, and we need to bring the jaws together, and we need to tighten the screw so that the cap would be held by the jaws properly. I have tightened the screw, and now the cap is adjusted properly between the jaws. It is held tightly. Okay. Now what we need to do, we need to look for the reading on the main scale. In this case, the main scale reading shows 2.8 centimeter. Okay. So we should write it down. The main scale reading is 2.8 centimeter for this cap. Now what we need to do, we need to look for the division of the vernier scale which coincides with one of the divisions of the main scale. So let me check, and I can observe here that the second division of the vernier scale coincides with one of the divisions of the main scale. So let it be P. The division, the number of division that is coinciding with one of the division of the main scale. So it is suppose P. So P is 2. So what is the vernier scale reading? We have already discussed that to find the vernier scale reading, we need to multiply it with least count. So P into least count, that will be 2 0.01 centimeter or it is 0.02 centimeter. So what we need to do now, we need to add these two values to find the observed reading for the length of this cap. So observed reading is equal to Mainscale reading plus Vernier scale reading. So 2.8 plus 0.02 centimeter. So that gives us 2.82 centimeter. So this is the observed reading for the cap. That means the length of the cap is 2.82 centimeter. Now what we need to do, we need to repeat this procedure at least for 3 times. Then we need to find out the mean value out of the 3 observed values. And if the Vernier caliper is having 0 error, then we need to subtract the 0 error from the mean observed reading, which will give us the accurate reading of the length of the object. Okay, hope you understand. Students, today we have discussed about the construction of Vernier caliper, different parts of the Vernier caliper, 0 error, and the procedure to measure the length of any object using a Vernier caliper. I hope you have understood everything clearly. If not, please watch the video again. Go through the diagram properly and you just need to remember the parts and their uses. Okay, and you need to do some practice to remember the procedure of finding out the length of any object using Vernier caliper. Okay, so as I always say, keep practicing, keep revising, and most importantly, keep smiling.